have another force acting upwards. Then I have another force here. So we have forces. I'm going to call them F1. I have another force F2. And I have another force, this is 2. I have another force F3. Now, to know that a moment, remember moment has to be force times distance, but it is the force that determines the direction of our moment. It's either clockwise or anti-clockwise. Now, for this that we have drawn here, we are going to see which one will take us clockwise, which one will take us anti-clockwise. Now, according to this body that we are having here, I want you to assume the force that we are onto, maybe F1, is acting alone on the body. And you put it in your head, you ask yourself, where would this force take our body? For example, if I have F1, I'm going to talk about F1 alone, then you will see others, F2 and F3. Now, if I have F1 as my force, I'm going to assume this force F1 is acting alone on this body. Now, according to what we see, since it's acting downwards, it is going to cause this side to move like this, whereas the other side will be moving in that direction. What does it show? It shows that my F1, it is making my body move in the anti-clockwise direction. Why anti-clockwise? Because for it is moving this way, downwards, so it will make the other part of the body move the other side, which is anti-clockwise. So it means that the moment, if I multiply F1 times its distance from the pivot or from this turning point, it is going to give me an anti-clockwise moment. So I want you to tell me, which moments will F2 and F3 give me? Which moments will F2 and F3 give me? You can tell us in the chat, or you can raise up your hand and you tell us. Which moments will F2 and F3 give us, according to you, according to what I've told you? You can write in the chat, or you can raise up your hand and give your answer. Yes, Kenneth?
Teacher, F1 will give us the anti-clockwise moments, whereas force 2 will give us the anti-clockwise moments.
Okay. And in the chat, Hannah, can you read us what is in the chat?
Teacher, they're basically saying that F2 is clockwise and F3 is anti-clockwise.
Okay, thank you. So I think now we can all tell which one is clockwise, which is anti-clockwise. From what Hannah has told us in the chat, is that F2 will give us clockwise, whereas F3 will give us anti-clockwise, which is so correct for that. So I'm sure now we can tell which force is clockwise and which one is anti-clockwise. Okay, now we are going to use the principle to do some few calculations because we have said that the sum of clockwise moments is equal to the sum of the anti-clockwise moments. And we saw that moments is force times the distance, perpendicular distance. Now we have a question here that we have a uniform meter rule. Now, before we continue, we are going to note down these two things. We may need them sometime. One of them, let me note them here. One of them is that for a uniform body, the weight acts in the middle. That is one. So if they talk about a uniform meter rule, a uniform something, its weight will always be in the middle of that body. Then the other thing is the other condition for a body to be in equilibrium. We have already seen one, that the sum of clockwise moments must be equal to the sum of the anti-clockwise. The other condition for a body to be in equilibrium is that the resultant force acting on that body is 0, which means that the upward forces, if we have any forces acting upwards, are equal to the downward forces. That is the other condition for a body to be in equilibrium. All right, that is a note that I wanted us to have before we continue. Now, in our question, we have that a uniform meter rule is pivoted at the center, and 3 forces, 6 newtons, 5 newtons, and F act at distances 20 centimeters, 60 centimeters, and 80 centimeters respectively from the 0 mark. If the meter rule balances horizontally, find the value of F. Now, what we are going to do is to redraw, or even if we don't draw it, I think it's to determine what is the distance of each of the forces from the pivot, and after that, we are going to go down to our calculation. Now, according to the diagram, you see that we have the 6 newtons at the 20 centimeter mark from 0. We have the 60 newtons, sorry, the 2 newtons from 60 centimeters from 0. And we have the F from 80 centimeters from 0. But remember, in our statement that we have made about the principle of moments, or even the definition, we said that the distance should be from the pivot. So our pivot is there at 50. So that means we are going to get the distance of 6 from the 6 newtons from 50. That means we are going to get the difference between the 20 centimeters, because this is at the 20 centimeter mark, and the 50 centimeters. Then we also get the difference between the 60 centimeter mark and the 50. And we also get the difference between the 80 centimeter mark and the 50, because that is what we are going to be using as our distances. That means the distance of 6 newtons, these 6 newtons here, the distance of these 6 newtons here from the pivot is going to be the 50 minus 20, which gives us 30 centimeters. Then the distance of 2 newtons, these 2 newtons from the pivot, is this distance 60 minus 50, which will give us 10 centimeters. And then the distance of F from 50, remember F is at 80 centimeters from 0. That means from 50, it is going to be 80 minus 50, which is also going to be 30 centimeters from the pivot. So someone is asking me about the distances. If the question is telling us that all these distances are from the 0 mark respectively, we have to get the distance. Our distance is distance from the pivot, because they were telling us that the moment is the product of force and its distance, perpendicular distance from the pivot or from the turning point. So all the distances of these forces that we have to use have to be from the pivot to that force, from the pivot to where the force is acting. And that is what I was taking you at. If from 0, 6 newtons is 20 centimeters, that means from the pivot, it will be 30. Then from the pivot, this one will be at 10. Then from the pivot, F will be at 30 also. And so we are going to start taking moments about G, or about the pivot. Taking moments means that we are going to know which one is clockwise, which one is anti-clockwise, and then we'll use our statement that we made to calculate F. Now, according to what we know, this one will be anti-clockwise, and these two will be clockwise. If we assume each of them is acting alone, I think that is what you'll be getting. 2 and F are going to be clockwise, whereas 6 will be anti-clockwise. Now, from the statements that we know that our moments, the sum of clockwise is equal to the sum of anti-clockwise. So that is what we are going to do. We are going to use the sum of clockwise. I'm going to call them C, and clockwise is going to be equal to the anti-clockwise. Anti-clockwise. Someone is telling that he has failed to know how we get 30. Let me first rub these ones here. Okay, I want you to look at what they have given us. They have given us that these forces act at 20, 60, and 80 centimeters, respectively, from the 0 mark. From the 0 mark. So this is our 0 mark here. What you see here is our 0 mark. This is 0. This one is here is 0. Now they have told us that this 6 newtons is at 20 centimeters from 0, but we are not interested in where it is from 0. We are interested in where it is from the pivot or from the turning point. So we are going to be looking for the distance of 6 newtons from the G, from the turning point, from this knife edge that you are seeing here. Now, the pivot is at the center of a uniform meter rule. So the pivot is placed at the 50 centimeter mark. But now, our 6 newtons is at somewhere where we have 20 centimeter mark. So for it is at a 20 centimeter mark on a meter rule. So that means that the distance from the 20 centimeter mark to the 50 centimeter mark is the distance between 6 newtons and the pivot. And the distance between 50 and 20, if you subtract 50 and 20, you get 30. That is where I've got 30 for that, because it has to be from the pivot. Now, 2 newtons, it is at the 60 centimeter mark. But what we need is the distance between the pivot and the 2 newtons. So that distance will be the difference between the 60 and the 50, and it will give us the 10. And we also look for the distance between the knife edge and the F. So the F is at 80 centimeters from the 0. But from the pivot, which is at 50 centimeters, we will be getting the difference between the 80 centimeters and the 50 centimeter, the marks of the F and the pivot respectively. So 80 minus 50 will give us the 30. So those are the distances that we are going to use. I hope we have got them properly. If we have got them, we are going to go back and continue with our calculation. Now, the clockwise moments, we have seen them. We have 2 newtons and F. Those 2 forces are going to give us clockwise moments, whereas the other one is going to give us anti-clockwise moments. So, we are going to get the sum of the moments. First of all, we have 2 times, allow me to use this, 2 times, its distance from the pivot is 10, but these distances are in centimeters. So as you calculate in moments, you have to change these distances to meters. Note me properly. If we are changing if we are calculating moments, these distances that you are seeing, the 30, the 10, have to be in meters. So we are going to use 2 times its distance from the pivot is 10 centimeters, but we are going to change it to meters. And instead of having 10, we are going to have 10 divided by 100, which will give us a 0.1. That is a distance of 2 from the pivot. I've told you we have to change to meters. Then we are adding on another clockwise moment, which is F. times its distance from the pivot, and its distance is 30, but 30 will be a 0.3. So we have 2 times 0.1. 0.1 is 10 in meters, and 0.3 is 30 when changed to meters. So those ones are the clockwise moments, and they're going to be equal to the anti-clockwise moments. Now we have only one anti-clockwise moment, which is 6 times its distance from the pivot is also 0.3 if we change it to meters. Okay. Now, after having that, we continue, and we will be getting our answer here. 2 times 0.1 is 0.2. So we have 0.2 plus 0.3 F being equal to 6 times 0.3 will give us a 1.8. So after having that, we are going to have our 0.3 F being equal to, we'll be having 1.8 minus 0.2, because now we are collecting like terms. The 0.2 will cross the equal sign and it become a negative. So we'll be having our 0.3 F, being equal to 1.8 minus 0.2 will give us 1.6. So if we divide through by 0.3 on both sides, we'll be getting our F as 5. So our answer, according to my calculator, is 5.33 recurring. And since it's a force, it will be in newtons, which is capital N. Okay, so that is our question, our example that we have had. And if you have got it well, I want you to do for me something small. So that was our question, and we got the answer for it. And now I want you to help me, and you do for me number 2. You see, first wait before we do number 2. Let us do these 2 questions. Question 1 and question 2. Question 1 and 2, they all want us to find the value of F. So you please try them out. Yes, Hannah?
There's a concern in the chat. Someone is asking why
Mm.
0.3 and 0.2 can't add.
We can't add 0.3F. The other one had F on it, eh? So one was 0.2, then the other one was 0.3F. So we can't add those two because one has F, the other is a constant. Okay, let us try those two questions. We have two questions in the chat. They want, in all questions, they want us to find the value of F. So you try them out first, then we continue and see.
Small. Helicopter. Helicopter.
All right. I think all of us have got answers. Yes, I'm seeing answers in the chat. Number one being 12.5. Number two, number two being 27 newtons. Yes. So we have the 5 and we have the 12.5 newtons and we have the 27 newtons. Now there is a question here that I want us to try together. This question number 2. Is here. We have a non-uniform tree trunk. Someone is asking me to help you with number 2, where we get 27. Okay. Briefly, this is how number 2 is going to be done. We have F giving us anti-clockwise, then 4 and 10 giving us clockwise. Now remember we said that moment is force times perpendicular distance from the pivot, and that distance must be in meters. So we'll be getting the 10 times the distance from the pivot. The distance of 10 from the pivot is 5 centimeters, and 5 centimeters is the same as 0.5. Then we are also going to add on a 4 times the distance from the pivot, 1 centimeter. No, this is 0.05 because it's 5 centimeters, not 50. Then 4 times, this one is going to be 0.01. And then this one is equal to F times the 0.02. So Julia, if you calculate well, you will have this one here as 0.5. Then we will add on the 0.04. and this side which has F will be 0.02 F. So you realize that if you add 0.5 and 0.04, you'll be getting a 0.54. So it means that we'll be having our 0.54 being equal to 0.02 F. And when you divide through by 0.02 F, you realize that you have your answer as 2027. So that is our answer for number 2. I was saying that we are going to try out this number 2. The reason I'm bringing it at the end is because it will need us to think more than the ones that we have done. It is saying that we have a non-uniform tree trunk whose weight is 1,000 newtons. And this one is placed on a pivot 4 meters from the thick end. A weight of 800 newtons is placed on the other end of the pivot at a distance equal to that from the thick end to the center of gravity. Just tips off means that so that one here means that the body at that point was at the center of equilibrium, because that is the only way we can we can do what? We can calculate this number if we assume that at that point, that is where we have our body at equilibrium. So if this is the tree trunk, remember it's non-uniform. We have a side which is bigger than the other. So it is pivoted at the 4 meters. So if this is the pivot, that is the pivot, and that pivot is at 4 meters from this end. So we have 4 meters. So they are telling us that we have 800 newtons placed at the other end of the pivot, a distance equal to that from the thick end to the center of gravity. So the center of gravity is a point where the center, the weight will act. But that weight cannot be in the middle, because now this one is not a uniform end. But they are telling us that the distance of if I've read well, at a distance equal to that from the thick end to the center of gravity. So if the thick end is this and the center of gravity is somewhere there, let me assume that one is our center of gravity. So that means that our 100 newtons will act somewhere there. This one is the center of gravity. Because this is the thick end, it is going to be this side. Distance that we don't know, so we are going to calculate it first. This is 1,000, which is the weight. But we have this distance should be the same as where we are putting 800 newtons from the pivot. So this is going to be our 800. Our 800 newtons. So they are telling us that the weight is placed on the other side at a distance equal to that from the thick end to the center of gravity. So if the thick end is that and the center of gravity is here, and that distance is x, maybe and that distance is x. So also the distance of this one is also x. And these people are asking us, how far is the weight from the thick end? So they are asking us, what is the value of x? Now, according to the diagram that we have drawn, we have the following things. We have this distance from here to the pivot is 4, but then the distance from the thick end to where the 1,000 is x. That means we have a distance from the weight to the pivot. That distance will be the 4 centimeters minus x. This distance here, I'm putting it in black. This distance here, the distance from where the weight is acting. This is our weight, and the pivot, the distance there is 4. The distance there is 4 minus x. Then the distance from the pivot to where the 800 is x, because they told us that the distance is equal to that of the thick end from the center of gravity. And I told you that the center of gravity of a body is where the weight of that body will act. That's why I'm assuming that the center of gravity is this way, where the 1,000 is acting. So let us take moments about the pivot, and you tell me what is the value of x that you are getting. This one is going to be clockwise is 800 times x, so it's 800x. It's going to be equal to the anti-clockwise, which is 1,000 into brackets 4 minus x. Why are we using 4 minus x? Because we say that the distance that we have to use to calculate moments has to be between the force and its perpendicular distance. Someone is asking us, how did we get the position of 1,000? Now, if you read this question here, if 800 is on one end, that means that the 1,000 must be on the other end. And being that this track is non-uniform, and we have one side, one thick end. Thick end means that one side is big, whereas the other is small. So that means that the bigger side will take much of the weight of the body. That's why I'm assuming the side which has the bigger end or the thick end is where the weight of the body is. It's where the 1,000 will be acting. That's why I'm assuming the 1,000 is at that point. So the 1,000 is giving me something like that. The 1,000 is giving me the anti-clockwise, whereas the 800 is giving me the clockwise. So according to what we have 800x being equal to, if we open brackets, we will be having 4,000, then minus 1,000x. Now, according to what we have, you see that if I collect like terms, this 1,000 is going to cross the equal sign. Because it has x on it, it will become a positive. So I'll be having 800x plus the 1,000x being equal to 4,000. And that one will give us 1,800x to be equal to 4,000. And what you get there is the distance of the weight from the thick end. I don't know, what do we get as x if you calculate well? 4,000 divided by 1,800. So someone is asking, why are we using one unknown? Yes, the distances are different. Now I want you to look at the question. The question told us that a weight of 800 newtons is placed on the other side of the pivot. That means 1,000 was on one side, 800 was the other side, at a distance equal to that from the thick end to the center of gravity. Now, I assumed that that distance from the thick end to the center of gravity, from this thick end to the center of gravity, I assumed it as x. But they told us that the distance where we put 800 from the pivot has to be equal to that distance. That's why we are using x and x, because that distance is equal, according to the question. But the distance of the 1,000 from the pivot will be the 4, then minus x. That is why we are using 1 and unknown. So the distance x will be 4,000 divided by 4,000 divided by 1,800. I don't know which answer you get, but that answer that you get will be in meters, 2.22 meters. Okay, so that is our distance, 2.22 meters. Okay, now that is briefly how we calculate moments. I have any other questions that we can calculate? And since we have done calculations, you allow me give you those questions. Let me look for them here. Then we will calculate them. We copy them and calculate. All right, there is an exercise that I've put for you on board on screen. It has questions. It has question 1, question 2, question 3. So we can copy up to question 6. Let us copy up to question 6, then we will try them out and we'll be getting the answers. Let us do that. Let us copy the questions and be trying them out. We still have 19 minutes to the end of the lesson, so we can do that for the rest of that time. And after, we'll be switching to computer. So let us start working from number 1 to number 6. All right, hope we have finished copying the questions. You will also allow me end this lesson here. I just urge you to please try those questions out and try and see if you can get the answers. End here, but I'm sure you're going in for the ICT training. So you stay on as you wait for the ICT teacher to take you through. I thank God who has seen us through this lesson that we have had about moments. There are more things that we have to look at. So in our next lesson, we'll look at more experiments and other calculations that may come up. Otherwise, you allow me leave you and you have a nice evening.